Okay, for the next part of the note here, I have 3 examples that I want to go through, and it's just practicing using your calculator. So you do want to have your calculator out for the next 3 examples here, and we're just going to practice punching it or doing the calculations. Okay, now the calculator on the computer here has an EXP button. It's down at the bottom. I'll highlight it a couple times. And there's the EXP button, so that's the one I'm going to have to use on this. So it's the same as the EE button, so you need to find your EE button times 10 to the X button or EXP button, and we'll move from there. So I just want to do a couple of operations here. So you can add, multiply, subtract, divide, exponential or scientific notation. That you do not have to convert. So for the first example, I've got 2.68 EXP 7. So that's on my calculator. That's what that first number looks like. Multiplied by 4.25 EXP negative 4. And that, again, that's what it looks like on mine. Hitting equals, you should be able to get this answer with your calculator, 11,390. Okay, so you need to try these out, because if you can't get these answers with your calculator, you need to talk to me tomorrow, and we'll do a couple practice ones. Make sure you can use your calculator properly. On to number 2, same thing, 3.98 EXP4. So that's what the top number of the numerator looks like, divided by 17.25 EXP negative 6. Doing division, and we end up with, and my calculator does not go to scientific notation. I wish it would, and I'm going to write the answer in scientific notation. So it's kind of a good practice here. So I'm going to go 2.307. So 2.307. I'm not going to do all of them. Times 10. If I bring it back up, count over. So I've got 369. So my final answer is going to be to the 9th. All right, there we go. So, well, there's the conversion button right there. 2.3, and there is the exponent 9. Okay, one last one. It's multi-stepped, so it's nothing overly complicated. It's just using the calculator to show you that you can do multiple calculations. So 2.95 exponent negative 12, and I'm going to do multiplication. I'll do the top first, the numerator, 1.78 EXP 6, and I'm going to divide that by 4.21 EXP negative 19. Final answer, 1.25, and that's the exponent 13. So 1.25 times 10 to the exponent 13. So you want to make sure that you can do these calculations with your calculator, and this is the calculator you're going to be using throughout the whole semester. So please make sure those are all checked off as you run through this. Okay, conversions of units. I'm not a big concern here because I'm more focused on the actual physics. However, you do need to know how to convert some of the units. So they're always troublesome in science. You're either going to be using a unit factor, which I'll talk about, or a unit conversion. We can greatly simplify it. So unit factor is a ratio made from a conversion that's accurately known. Okay. So some of the conversions are basic conversions that we know. We know there's 1,000 millimeters in a meter. We know that there's 100 centimeters in a meter. We know that there are 10 decameters, which we don't see very often, so I'm not going to do that. We know that there's 1,000 meters in 1 kilometer. And then there are a couple other ones that we're going to run into throughout the year. For example, micrometers and so on and so forth, but we'll deal with them as they arise. Okay. Basically, how do you do that conversion factor? It simply looks like this. So let's say we want to go you have 3,400 millimeters is equal to how many meters? So I'll show you the process that works for all conversions, and we can go from there. So I'm going to look for the conversion that involves millimeters and meters. So it's right here. So I know that 1,000 millimeters is to 1 meter. So this is ratios back from grade 9. And that's going to equal, I'm going to keep my millimeters lined up, 3,400 millimeters to how many meters? Okay, So the question is, what's my multiplication factor? How do I go from 1,000 to 3.4? Well, I would multiply by 3.4, which means my final answer would be 3.4 meters. So you need to take these known conversions, and you're going to find them in the textbook, and I'll show you where they are so you can find them. One of the main calculations or conversions that you're going to have to go with is kilometers per hour to meters per second. We always work in physics in SI. So in physics, we always work with SI units. In your SI units, we want everything in meters, seconds. What else do we measure here? Meters and seconds. Yeah, that's pretty much the standard. If I think of one, I'll leave a space. So we want everything in meters and seconds. So if we had, for example, 42 kilometers an hour, then we got to make a conversion here. Okay, so we need to know some basic calculation, or we can do a line calculation. So what I'll do is I'll show you the line calculation, and then I'll tell you what the shortcut is from there. So if we have 42, and I'm going to write it as a fraction, kilometers in 1 hour, I want to move this to meters per second. Okay, so that's what my goal is. All right, so 42 kilometers per hour is how many meters per second? Well, the first thing I want to do is I want to get rid of the kilometers. So if I put 1 kilometer on the denominator, I can cancel out the kilometers per hour, or kilometers will cancel, but I have to keep the equation balanced. How many meters are in a kilometer? Well, we know there's 1,000 meters. So now when kilometers cancel out, I am now into the units of meters per hour. Okay, so now I got to get rid of the hours. The only way I can cancel out the hours is by putting it on top. So 1 hour, the h's would cancel, but I have to keep the equation balanced. So how many, and if you want to think of it this way, how many minutes are in an hour? So we can go with 60 minutes. We don't want minutes though, so 1 minute has 60 seconds, and those minutes would cancel out. And with a line calculation, you just calculate across the top. So I have 42 times 1,000, so that would give me 42,000 on top. And my units would be, the only thing left is meters, divided by, and multiply across the bottom. 60 times 60 is 3,600 seconds. So now we can do that calculation with the calculator. We're just reducing that fraction essentially. So 42,000 divided by 3,600 equals 1.16. All right. So if I get it out of that, 11.7 meters per second. Okay. What I'm going to do though is let's just chunk it down. Let's leave the 42 for a second, and let's just look at the end segment here. Okay. If I take a look at that end segment, I ended up with 1,000 on top divided by 3,600. If I reduce that fraction, I get 10 over 36, and if you take it one step further, I would get 1 over 3.6. So what you'll want to put, and you get a, I call it a cheat sheet, but some teachers call it study sheet. On your study sheet, this is what you'll want to have, and you want to have this somewhere where it's handy. If you want to go kilometers an hour to meters per second, you are going to divide by 3.6. So you're not going to actually do that conversion or calculation I did above. I'm just showing you a situation where you don't know what the conversion factor is or the unit factor is. So that's how you would do it. Do you have to do it every time? Absolutely not. So there are rare occasions. So you're definitely not going to be doing that conversion every day. Vice versa, if the question wants the answer in kilometers per hour, then you would do the opposite. You're going to multiply by 3.6. Okay? So those are two conversion factors that you need to know because you often have to do those conversions. Okay, and as for the line calculation, I picked an example where you're going to use it often. Are you going to use this often? No, you are not. But I want you to have a process in place if you come across something you're not sure of. Okay? So if you're not sure of, you just set up a line calculation and you can do the conversion. Okay, review of algebra skills. I'm not going to spend too much time on this because you should be able to solve the following. So what would I expect you to do? I expect you to be able to solve, your one-step problems. So 3x equals 12. I would expect people to go x equals 4. 2 steps for sure. The 4x plus 5 equals 9. I would expect people to be able to get through and tell me that x equals 1. Beyond that, we're not going to run into crazy linear ones. You will have some algebra or some quadratics to solve. So for example, let's say we had 4x squared equals, let's go with something simple at this point in time, 9. So I would expect you to be able to do x squared equals 9 divided by 4. And x equals, so when you take the square root of something, and this is something I need to emphasize right here, when you take the square root of a number, it's equal to plus or minus the answer. There are 2 solutions. Okay, you talk about that in the grade 10 course, grade 10 math course, that there are 2 solutions in a root. All right, sometimes the -1 is valid, so it'd be plus or minus the square root of 9 over 4, which is plus or minus 3/2. So there are 2 solutions. And do I expect you to be able to common factor? Yes, common factoring is a skill. So for those that didn't do any of the factoring or are struggling with factoring, it does come up a little bit in the first part of this course. So I would expect you to be able to solve 6x squared plus 2x equals 0. So I would expect you to be able to go, okay, so 2x comes out, and I'm left with 3x plus 1 equals 0. And I would expect you to be able to tell me the answer to that. So the solution to the first part here, x would have to be 0. The second part, to make that equal 0, it would have to be -1/3. Okay, so when do 2 cars collide, or when are 2 cars at the same point? 0 and -1/3 of a second. Okay, very important that you can go back and forth. So you will have to do some factoring. So if that's the area of concern, I can definitely give you some worksheets with that. Quadratic formula is a must, okay, especially in the kinematics unit. And for those that are heading into the 4U physics course, quadratic formula is extremely important. So just as a quick reminder, ax squared plus bx plus c equals 0. That's your quadratic formula. For us, it's usually going to be t in there because we're going to be looking for time. So x equals -b plus or minus b squared minus 4ac. I don't know why I'm using capitals. It's not really necessary. And from that, I need you to be able to understand the discriminant. All right, the discriminant is very important. We talked about it a little bit in the grade 10 math course. Very, very important here, because if b squared minus 4ac is smaller than 0, which means it's a negative number, there's no solution. In physics, that's important, because if I say at what time will 2 cars collide, if the discriminant's a negative number, it's never going to happen. So that's case 1. Case 2, b squared minus 4ac is equal to 0, then there is one solution. So that means if I ask when will 2 cars collide, there's only one chance for that to happen, and it occurs at this time. And finally, the third situation, b squared minus 4ac is greater than 0. Then you end up with 2 real roots, I think is the terminology used in the grade 10 math. 2 solutions. Also very important, because if I ask when will the cars collide, you can tell me, well, if they miss each other at 2, they'll have another chance at 6. Okay? So very, very important that we understand that. And like I said, for the grade 12 course, it's even more important. All right. We will cut this video off at this point, and I will meet up with you in the next segment.